All right, so this video we're going to talk about permutations. So what is a permutation? A permutation is an ordered arrangement of items that occur when no item is used more than once and the order of arrangement makes a difference. Okay? So no item is used more than once, and the way that you choose the items makes a difference, the order in which you choose them. All right, so let's look at example 1. Okay. So it says, in how many ways can the 6 jokes about books be delivered? If Bob's joke is delivered first and Jerry's joke is delivered last. All right, so I got this problem out of a book, and they have these different people that tell a joke, and they actually have the joke written out in the book. I didn't want to write all that out, so Bob's joke, it's this. That's what the 3 dots are. I just didn't write it out. I'm just using this as this is his joke, this is Dan's joke, this is Jerry's joke, and so on. All right. So what we're doing here is they're going to tell 6 jokes. Each person has a joke. So here's the 6 people. 1, 2, 3, 4, 5, and 6. All right. So how can they be delivered? All right. If Bob's joke is delivered first and Jerry's joke is delivered last. All right. Now, in this case, remember, these are permutations. The order makes a difference. Okay? So you think about it. We're going to deliver, and I'm going to show you how this order makes a difference. So let's just suppose that they deliver the jokes like this: Bob, Dan, Jerry, Bill, Ben, and Stan. Okay? That's how the jokes are delivered. Okay? And then let's say that we do Dan, Bob, Jerry, Bill, say Stan, and then Ben. Okay, so see, it's the same people telling a joke. You see that? All 6 people are the same, but notice what I did is I switched the order of these last 2. That's a different arrangement. Okay, it's a different arrangement of how the jokes were delivered. So that's what they're saying there for the permutations. This is different than this because the order changed. Okay, so it's different. Okay, all right. So in how many ways can the 6 jokes about books be delivered? All right, so just draw some blanks. 1, 2, 3, 4, 5, 6. That's the 6 jokes. And what we want to know is how many different choices do we have for this one? How many different choices do we have for the second joke? How many different choices do we have for the third joke, and so on? All right. So let's look at this. So the first joke. How many different choices do we have for the first joke? Well, there's 6 people, right? All right. There's 6 people, 6 choices. But what does it say? Bob's joke is delivered first. So Bob's joke has to be delivered first. So we only have one choice here. There's only one choice. It has to be Bob. And then, before we go on, let's look and see what else it says. And Jerry's joke has to be delivered last. So let's go to the last joke. How many choices do we have for that? Well, we only have one choice. That has to be Jerry's joke. Okay? So now let's fill out all the stuff in between. There's no restrictions on that. What we did is we filled out all the stuff that had some restrictions on it. The first joke had to be by Bob. The last joke had to be by Jerry. Okay? So if I look here, how many choices do I have for the second joke? Well, I've got what? 4, don't I? See, there's 6 people total, but look, Bob has already told his joke and Jerry's not telling his till then. So Bob and Jerry, I can't use those. See, I only got these 4 left to fill in here. You see that? All right, so I had 4 choices here. Well, how many choices do I have for this joke? Well, I only have what? 3. Because see, the 4 that were remaining, one of them told their joke here, so now there's only 3 left. All right? And then another one told their joke here, so how many choices do I have for this? Well, I only have 2 choices. And then for this joke here, I only have 1 choice. I hope that makes sense. And so how many different ways? Well, 1 times 4 times 3 times 2 times 1 times 1, and that's going to be 24 different ways. All right. All right, let's look at the next example. All right, so you need to arrange 7 of your favorite books along a small shelf. How many different ways can you arrange the books, assuming that the order of the books makes a difference to you? All right. So they told us in this problem that the order makes a difference. Okay. And I know in this video so far I've talked some about order makes a difference. And yes, there is some problems where order does not make a difference. And that is talked about in the next lesson, combinations. That'll be a separate video, okay? If you're on this playlist, just look at combinations. And in that combination video, I'll talk about differences between permutations and combinations, because that's usually what students have the most problems with, is figuring out, well, is it a permutation or is it a combination? Sometimes it can be difficult to decide which is which. All right, so I'm going to arrange seven of my favorite books along a small shelf. How many different ways can I arrange the book? Order makes a difference. Okay, and if they didn't make a difference, if it didn't say this, that order makes a difference, if it did not say that, you would still say that, well, order makes a difference. Because you think about it, if you have a shelf here, and let's say you have, let's just use 3 books, book A, B, and C, okay? These are your books here, okay? There's your books. Well, that's an arrangement, but what if I come on the shelf and I arrange them like this? Okay, it's the same books, but isn't it a different arrangement? You see the order made a difference there. Okay, the order makes a difference because this arrangement is different than this one. All right, and I would really recommend you watch that combination video, because I talk about the differences in that video, and I do have another video that you can search for on my channel. Search my channel for differences between combinations and permutations, and that's all that video is on. So, check that out. All right, so we want to arrange 7 books. So, well, let's just make 7 spaces. Okay, so there's our 7 spaces. Now, for this first spot for the book, how many choices do I have for this first spot here? Well, I've got 7 choices, don't I? There's 7 books sitting there, and I'm going to grab one of them and put it in that first spot. So I can choose from any of the 7 books. There's no restrictions on this one like in the first problem. All right. Now, when I go to the second, okay, I go to the second position on the shelf. All right. So how many choices do I have here? Well, I have 6 choices, right? Because remember, from the for the first spot, I had 7 choices. I took one of those books and I put it on the shelf right here. Well, that book's not up there anymore. There's only 6 books left, so I only have 6 to choose from. All right. And then for the third spot, how many? Well, there's another book gone in the second spot, so there's only 5 books left to choose from. And then 4, 3, 2, 1. Okay. And so this is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1, which that comes out to be 5,040 different ways. All right. Now this right here, what we did there, that's kind of special there. Okay. Of what we did. I mean, you think about it, on some of these you could have 20 times 19 times 18 times 17 all the way down to 1. You don't want to put all that in your calculator. You don't want to put all this in your calculator either. So there's a special notation for this 7 times 6 times 5 times 4 times 3 times 2 times 1. There's a special notation for that, and there's a button on your calculator for it too. And that is called factorial. Okay? If n is a positive integer, the notation n and then this little exclamation mark, that's read n factorial, is the product of all positive integers from n down to 5. So n factorial is n times n minus 1 times n minus 2, all the way down to 3 times 2 times 1. And then by definition, 0 factorial is 1. Now, as far as how to punch all this into your calculator, I'm not going to go over that because y'all have different calculators and there's no way I could explain one way and that covers every calculator. The best thing to do is just get out your manual. Some of the cheaper calculators, if you pull off that cover, it'll have a little card there in the back of it, on that little cover, and you can just, it'll show you how to do it. So let's look at these examples here. It's factorial. So 5 factorial. Well, 5 factorial, that's what? That's 5 times 4 times 3 times 2 times 1. See that? And that is, I believe it's 120. Matter. Let me double check, make sure, but I think that's what it is. I know if I get it wrong, I'll hear it in the comments. All right, yeah, 120. All right, so that's all it is. Whatever this number is, it's just that number all the way down to 1, multiplying them together. That's all it is. All right, now let's look at this. 8 factorial divided by 5 factorial. Well, this is what? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over, and then 5 factorial is 5 times 4 times 3 times 2 times 1. All right. So if you look at this, you see how I wrote this out. Now, I wrote this out the long way. I wrote everything out on purpose on this one. Okay? And what I'm writing right here, you're not going to write all that out every time. Okay? I just want you to see this. Do you see this and this are the same thing? All those cancel out, don't they? And you might be thinking, yeah, well, I just cancel them all out. Yeah, that's fine and everything. But what I want to do is I want to rewrite this a little. I want to write another step in there. So this is actually what? 8 times 7 times 6 times, and look at this. See how both of these, they're 5 times 4 times 3 times 2 times 1. Well, what is that? What is 5 times 4 times 3 times 2 times 1? That's 5 factorial, right? Over, and then this is 5 factorial. You see that? And now these things cancel here, and I'm just left with 8 times 7 times 6. And so that is what? 336. All right. So you might be wondering, okay, well, why did you write this out and then go back to this? Okay. Well, I did that to show you how to get this right here, the 5 factorial and the 5 factorial. This step right here is the step you're not going to do. Okay? When you start writing this 8 times 7 times 6, and then you get to 5, well, you know in your head that's 5, 4, 3, 2, 1, which is just 5 factorial. Okay? So you would go from this step here to this step here. And let me say, it might, you might see it better when you write it out like this and then go to this step, or you might prefer just to write this out and cancel them out individually. But let me tell you, you don't want to do that. You want to understand how to go from here to here. And the reason, do you want to write all that out? You see that? Do you want to write out 26 times 25 times 24 all the way down to 1? And then the same thing here. And then actually look at that next problem there. You see that? You don't want to write out 500 times 499 times 498 all the way down to 1. You don't want to do that. Okay? That's why I showed you this. Okay? And what's going to happen is you're just not going to put this step in there. I just wrote that step out so you could see how to get to this one better. All right, so let's look at this one. So this is equal to what? 26 times 25 times 24 times 23 times 22 times 21. But look, I know this is going to go 20, 19, 18, 17, all the way down to 1, which is just what? 21 factorial over 21 factorial. Whoop. Over 21 factorial. And see, now the 21 factorials, they cancel out. And that leaves me with, 7,893,600. All right. So because all I did, I just multiplied 26 times 25 times 24 times 23 times 22. Okay. All right, now let's look at the next one. So, when you first see this one, wow, those are big numbers. But let's look at it. So that's what? 500 times 499 times 498 all the way down to 1. But look, I've got the 499 factorial. 499 times 498 all the way down to 1. That's factorial, right? Over 499 factorial. And then look what happens. Those cancel. And this is 500. All right. All right, so now let's look at this. Let's look at permutations of n things taken r at a time. Okay? Permutations of n things taken r at a time. All right, so the number of possible permutations if r items are taken from n items is, and this is the notation used, NPR equals n factorial divided by n minus r factorial. Okay, all right. So let's look at an example and see what we got. So example 4, you and 19 of your friends have decided to form an internet marketing consulting firm. The group needs to choose 3 officers, a CEO, an operating manager, and a treasurer. In how many ways can those officials be chosen? Now, we're using a permutation. You know we're using a permutation because that's the section this is in. But you think about it, when you take tests on this stuff, it's not going to tell you permutation, combination. Permutation and combination problems, they're all going to be mixed together, and you've got to decide which one to use. Okay? But yeah, we know this is a permutation here. So let me just kind of briefly explain how this is a permutation. All right? So we've got what? Well, let's write out what we're looking for. So this is a permutation. So we have permutation. How many things are we choosing from? Not how many are we choosing, how many are we choosing from? Well, that's 20. Okay, N is 20. Because it's 19 of your friends and you, so there's 20, have decided to form an internet marketing consulting firm. The group needs to choose 3 officers, and we're choosing 3 people. So that's N items, choose R of them. Okay, so I've got 20 people, and I've got to choose 3. All right. Now, let me erase this real quick and write that formula down. So that's N factorial over N minus R factorial. And I have 20p 3. Okay. Now, before we plug this into the formula, let me just go over this. So let's say you've got your 20 friends down here. So let's say you have A, B, C, D, E, F, G, and so on. Your 20 friends down there. These are their names. This person's name A, this person's name B, this person's name C, and so on. You got 20 of them. All right. And the positions we want to fill a CEO, an operating officer, and a treasurer, right? All right. So let's choose these people. So let's suppose I choose A, B, and C. Okay. So A is the CEO, B is the operating officer, and C is the treasurer. Okay. So I chose A first, I chose B second, and I chose C third. All right. Now, let's choose in a different order. Let's choose the same 3, but in a different order. So let's suppose I choose C first, then I choose B, and then I choose A. I chose the same 3 people, but remember, in the first time I chose, this was A, B, C, right? And now this time that I chose, I've got C, B, A. It's the same people, but you see how that makes a difference? The CEO is a different person. The treasurer is a different person. See that? The order that I chose them made a difference. Okay? And that's why that's a permutation. All right. So now let's calculate this. So I've got 20 factorial over 20 minus 3 factorial, which that's 20 factorial over 17 factorial. All right. And so now, simplifying just like we did before, that's going to be 20 times 19 times 18 times 17 factorial over 17 factorial. The 17 factorials cancel, and I am left with 20 times 19 times 18, which is 6,840. All right. Now, let me say this. The permutations here, this formula you have, you are not going to calculate those things using this. Okay? There's a way that you can calculate these permutations and combinations. We'll do those will be in another video. But combinations and permutations, you can do those on a calculator. And like I said, I'm not going over how to do it because there's different calculators out there and there's no way I can cover all of them, you know, and I don't have every calculator out there. But I do have some videos on there on how to calculate combinations and permutations on the calculator. You can search my YouTube channel for that. But yeah, this right here, you can actually just punch this into your calculator. You would type in 20, and then you've got to find, there's a button that looks like that. You've got to find that. Some calculators, you got to have a button and it pops it up on the screen where you can choose this. And some of them have this on the calculator where it's either on one of the keys or above one of the keys. But you would type in 20, then you would hit that, you would need to find it, and then you would type in the 3 and hit equals, and it would give you the 6,840. All right, so let's look at this one. All right, so example 5. In a production of West Side Story, 8 actors are considered for the male roles of Tony, Riff, and Bernardo. In how many ways can the director cast the role? All right, so this is the same thing. These are specific roles here. Okay, Tony, Riff, Bernardo. So it's going to make a difference who I choose first, second, and third. See, the first person I choose is going to go to Tony, the first person to Tony, the second person to Riff, and the third person to Bernardo. All right. So the order that I choose them makes the difference. Well, we know this is a permutation. So this is permutation. And I have what? 8 actors. So N is 8. And I'm choosing 3 of them. I need 3 of them to fill those roles. So that's 3. And look, I'm not even going to plug that into the formula. I'm not even going to write out the formula. Just go straight to your calculator now and plug that in. If you don't feel comfortable doing that, then do what I did here. And then you'll end up with something like this. And we just did a bunch of examples of those up here, of how to simplify those. Okay? But yeah, on this, just get your calculator out and plug it in. And let's see, I have to do that. 8, and then I've got permutation, choose 3. And this actually just comes out to 336 different ways. Okay. All right, so I hope that made sense on that one. And this is the last example. All right, so permutations of duplicate items. It says the number of permutations of n items where p items are identical, q items are identical, r items are identical, and so on. Okay, just however many identical items you have. Okay, so is given by n factorial divided by p factorial times q factorial times r factorial. Okay, and that's all it is. Let's look at an example and make more sense. So in how many ways can the letters of the word Mississippi be arranged? All right, so the first thing we have to do is let's look at how many letters we have total. Well, we have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 11 factorial over, and now we got to divide by the duplicate items. Okay? So let's see. What all items do we have duplicate? Well, we've got the I. There's 1, 2, 3, 4. There's 4 I's. Okay? And so those are duplicate. So I've got to divide by 4 factorial. And then let's look at the next one that's a duplicate. The S's. I've got 1, 2, 3, 4. 4 S's. And so I've got to divide by that. So times 4 factorial. And then the next one that's duplicate, that's the See the p's? Well, how many of those do I have? 2. And so that's times 2 factorial. And then when you multiply all that out, 11 factorial divided by whatever that is, that's going to be 34,650. And that is all of this video. We're done. All right. So I hope this made sense. Check out my other videos. Give me a like, share, and subscribe. And thanks for watching.